Hey, folks, welcome to this session on Leads SD Skills Daily Lead Code Practice. So we have Ashish today who will be walking us through the questions that were posted yesterday. If you haven't done so already, please join the SDA Skills Slack. The link is sdaskills.com/Slack. And then if you want to look at the previous questions that we've discussed, the previous videos, the archives are available at sdaskills.com/leadcode. And the last but not the least is that we do have a specific channel called Lead Code Practice, which is where we discuss these questions and post these questions pretty much on a daily basis. So with that, let me hand it over to Ashish, and we can start today's session. Go for it.
Yeah, thanks Vivek for the introduction. And hello everyone. So we are again back with the daily lead code practice sessions. So let's start with the easy problem. It's from the easy bucket, and the name is distribute candies. So we are provided with a integer array, and the length of the array is even. It is mentioned over here, and we are provided with different kinds of candies. As you see, we have one as a one different kind of candy, and two as a different one, and three as a different one. So each number means one candy of a corresponding kind. So what we have to do is we have to distribute these candies equally in number to brother and sister. Like in this case, if we have three candies, then six candies, then we have to distribute these six candies, three to the brother and three to the sister. And we have to return the maximum number of different kind of candies that sister could gain. Like we just have to maximize such that the sister have distinct candies. Like uh, we don't have to give her two, three, and the same candies every time. We have to distinct. We have to give her distinct candies. That is our main aim or goal to achieve. So I think the question is clear to everyone. Is there any questions regarding the problem statement? Anyone? Okay, fine. So uh, anyone tried solving this question or?
Hi Ashish, hi everyone. I'm Tanmay.
Yeah, hello, Tanmay.
Okay, so basically what I did was I just iterated over the array and I just kept a count of like the numbers I'm visiting. Like how do I explain it? Firstly, I found out the maximum and then I made an array having of maximum size. Um, uh, in the first case, it's 3, and then I iterated over it again once again, and what I did was I just counted the total number of different characters that I'm getting, different integers. If it's greater than n by 2, then what I did was my answer was n by 2, and if it's less than n by 2, so my answer is that number plus 1 basically.
Yeah, I did somewhat like that only. I just kept a count on the distinct number of candies, and if the distinct number of candies was greater than the n by 2, then I returned the n by 2. If it had four distinct candies out of six, then I returned 6 by 2, that is 3. And if it was less than that, and then I returned just the number of distinct candies that can be at max. So I did the similar, somewhat like you only. But I would like to suggest one more thing. Like despite I used a unordered map or a hash table for this to get the distinct count. But can we use set instead of that? Like which one will be more faster and which one will be more like apt to this to find the distinct elements?
Hi. So I have a question like why you use map? So what's the use of map over here? We can do it in a set also.
Yeah, that what I'm asking. Like, which one will be better, like in terms of time complexity, like converting into a set, or just using a ordered map.
I
That's
think
my
a
question.
set would be fine for,
Yeah. So,
yeah,
uh,
set.
any specific reasons like why you're saying that?
Uh, so here in map we are using the key value pair, which is extra taking an extra space, I suppose.
Yeah, but I guess if we will be using a set, then it also takes a space, right?
Hmm.
Okay. I
Does
when is some
so one question is that does SAT keeps the uh, unique value or all values?
no, the set just gives us the distinct integers we have.
Okay.
Yeah.
Set is basically union find, right?
I'm not into much type of set, but I just know the fact that it doesn't have like same elements or repeating elements.
Okay. Because I never use sets. I just like
Yeah,
make an array and then give it a run.
yeah. It's we have set in Python as well as in C++. I don't know about Java as much, but we have in Python and C++ both.
So can you hear me?
Yeah, yeah. Please go ahead.
Yeah. So you are only interested in getting the distinct count here, and that is
Yeah,
what the set serves. It's the purpose of set to give you that. Map is a bit generic. You can have not just count. You can do anything with it because you have the key value there, right? So
yeah.
think about all the trees problem you can solve easily using graph, but that is quite generic. So your problem is getting solved just by using set, so you can do it. As far as implementation is concerned, as somebody already posted, you might have seen internally at least in Java, uh, the key value is same in case of hash set. So you are not getting any advantage, but you are showing to the interviewer, hey, I know the core purpose of this data structure, so let me use that here. Other thing, somebody was talking about disjoint set. No, sorry, union find. That is a different data structure. It is called disjoint set, and it's don't get confused. It's for a different purpose. Just want to clarify.
Okay, sure.
Thanks.
So, in this question, like whether we are using set or a hash table, I guess we're using a space apart from the constant space. So, can we do this in just like constant space of big of one? Is there any approach?
One would be difficult, right? We at least need to know the unique numbers. So we go through whole array once.
Yeah, yeah.
But
That's
it would be less than the order of n because space would be less because we are using the distinct one set. So it will take less space.
Yeah, I would say it's dependent on input. So you can't say that it is always less. What if all?
Yeah.
I haven't
so.
tried, but sorry, is the input sorted by any chance? Like, is it one, one, two, three, three? Is it coming in that particular order?
No,
Not
no. I think
necessary.
we have to sort manually if we need to
Okay, so if
sort
you
it.
are going to, if you are trying to optimize space, then you have to give up on maybe time complexity and you can think in that direction. Like, will it help you if
Yeah, yeah. The
you
thing
have,
is, like, if we are doing this in big O and the sort thing will give us analog n. So that's the like
exactly?
that will be
So,
one different. Uh,
yeah, so saving space means you are losing time. And that is the
yeah,
thing, like, that I always have to deal with that kind of
yeah. Okay. So are there any other approaches, or shall we move forward to the next question?
Yes, we can move forward.
Okay, okay, sure. So the next question was from the medium bucket, and it's like to find all the duplicates in an array. So we are given with array, and we have to find like those elements which are appearing twice, and we have to push them into another array or something. So, and we have to return that. So we are given with an array which in which some elements appear twice and the other appears once. So we have to find all the elements that appears twice in this array. And the kick over here is that we have to solve this question without any extra space, and we go fn. So it's basically they are asking a question. I don't know. It's must to solve that. So
Um,
is,
Okay.
is there any question regarding the
Hi.
problem?
Hello.
Yeah,
Hi. My name is Rohan.
yeah, Rohan.
Very looking at it right off the bat, I think I can do it in nlog n, where you just sort it and check adjacent elements. If there is an adjacent element which is the same, then just what is it asking for? Find all elements that appear twice. If there is an adjacent element, add it to a result array. Just append it. But this is nlog n of
that would
course.
be n log n. So I tried with order of n approach.
Yeah, please go ahead.
So what we can do, as it's mentioned that we can do it, we have an array of integers between 1 to n. So n will be the
Yeah,
size of the array, which is like our elements will be between 1 to n minus 1, correct?
yeah, yeah,
So think like we have an array, and so for each element we can make it a negative. So if at each place, and if at particular place, if we already negative is occur um, is placed, then we can say that it's that number is already comes. So we that would be our result. So is it like you are getting my
Yes,
point?
sure. That's it's a standard geeks question, like standard interview question, and that's the approach we
Yeah,
follow. What we do is we just iterate over the array.
yeah,
For in case if you see the example, I'm getting 4. I'll mark the number at idx 4 to be negative. The
yes.
next time I'll get 4. I'll check at that index. If my number is negative, I'll just add it to my answer. That's the approach.
Yeah,
Nice.
that's the approach.
Yeah.
Uh,
yeah. Fine. So the if somewhat if we have numbers not from 1 to n, like we can have different numbers, then I guess it's not possible to
yeah,
do that.
that it would not be possible because then we don't know how much our array size would be like
Yeah.
a, a bigger should it would be bigger.
Okay. Fine. So if the question was like kind of reverse, if we have to find the numbers which appear once, so in such case we generally use a XOR approach.
Yes,
Like
yes, the XOR would work. Yes.
yeah, but can we implement XOR in this case, like in anyhow, if we could? And it's just a question. I'm not sure.
Mm.
Could you like tell me what's the Zor approach? I didn't get it by name.
So let's say the question was kind of reverse. So if we have to find the number which appear once. So but in this case, like we can have multiple numbers. So but let's say we have just one number, single number, which appears one time, and other appear twice. So what we do, we took a XOR of all the numbers, then the resultant number will be definitely.
But yeah, I got your point. But in that case, the XOR, how XOR would work, it will cancel out the same numbers. But
Yeah,
if
yeah,
we have
that's what
a
I was saying.
like we have then we come up with only the numbers which are left,
Yeah.
and so it would be difficult to distinguish the numbers from like what are the
At
numbers,
least
for
at
example.
least at least we will get like what numbers are present like a single time, and then we can iterate once again and like look over the array.
But
If you
how we
wouldn't
can
mind, could you just like give me a dry run of the Zor approach? I didn't get it. That how you code it.
So let me open my notepad. So if we have like numbers one one sorry, 1 1 2 2 and 3 3 and 4. So here we can see that 1 is appearing twice, 2 is appearing twice, 3 is appearing twice, and 4 is appearing for one time only. So what we are doing, like we have to find the number which is appearing once. So we can took a XOR of 1 1 2 2 3 3. So this will become 0, and we are left with 0 XOR 4. So we will get like 4 as a single number which is appearing, which is non-repeating.
Will this be working in order of n?
Yes.
Yes, obviously we are just
Yes.
we are just taking a XOR of each element of the array. So definitely it will take big of that.
Okay, I got it. Thanks.
Yeah, and I think we can also find two different distinct numbers which are non-repeating. There is one method. Uh, we have to partition the array, and then we have to look to the rightmost kth bit.
But
So
that would be for two elements, like
yeah,
two. But I don't think so. We can go for like more than two to find.
oh,
We have this approach, Malab. We're searching for the elements that are negative. In this case, we'll search for the elements that are positive.
pardon, what do you mean by negative?
As we did this question, what we did
Yeah,
was a number that appeared twice, we marked it as negative, right?
yeah.
So, like, now I'll be having numbers that are not marked as negative. As in, if a number is has appeared just once, I'll not mark it as negative, right?
Okay.
So I'll just get the answer, then I'll iterate over the array. It's just upon like when you mark it as negative. For in case for this question you're marking, whenever you say it first, you're marking as at negative, right? The second time you say it, you mark it as positive. Like, we'll do something like this, and like we'll kind of get the approach.
Okay. Um, but I'm still not clear what are you saying.
Let me just think. I'll explain it.
You want to share your screen, then you want to explain something.
Give me a bit of time. I'll just do trial and I'll let you know.
Okay, sure.
So we were talking about the XOR for taking more than two. Is it possible to get a single number from them? So, for example, if we are doing a XOR of this input, we'll be
Yeah.
we'll be canceling out all the duplicates from here, and we'll be left only the singleton elements. So, how we
Yeah.
can distinguish which uh, the elements which are singleton from here? Like we'll be having the XOR of all the numbers. So how we come up with what number it is, like 4, 7, what number, how we come up with the number?
Yeah,
That's
if there are only two singleton elements, then it's easy to get the other two numbers.
yes.
But it's
Yeah,
tough to get like all the singleton elements if it's more than two. So
correct. Yeah, then it
not
would not be
possible to
possible.
get. Yeah.
Yeah. So if the question is that we only have, if we only have two elements, I think we have done this question somewhere. So then
Yeah.
it would be possible to do with XOR.
Yeah, but still we need extra space for the XOR because
I guess I got a solution. Kind of just listen to me. For in case, let's take an example of like um, 1 1 2 2 3 3 and 4 and 5,
You
something
want to
like
share
this.
your screen, Tanmay?
Okay, I'll do it.
okay, wait, let me stop. Right.
Okay. Is my screen visible?
Yeah.
So let's take an example of 1 1 2 2 3 and 4 4 and 5. Okay. So when I'm like iterating over this, I just need two things. The first one is the have I the size of this array is 7. So I need to check that if like for in case I'll just go with my approach, I'll just go with dry run. I encounter 1. What I do is I mark it as -1. I encountered it once. Okay, and I'm having a 0 that's like a 32-bit this thing bit. It's just a bit number. So what I'll do is I'll make the first position of my that 0 number bit position to be 1, which means that I've encountered that number. Now I'll move to the second place. I'll see that I've encountered one once more. I'll make it positive. Got it? Now what I'll do is I'll move to second the next place. I get 2. I'll make the second place as negative, and what I'll do is in my bit number I'll make the second place as 1. Now what I'll do is I'll just move to I'll just keep on progressing, and finally what I'll get is my this number will be positive, which means that I have encountered one more than once, like twice. I've encountered second number again twice, because this is gonna be positive. But for the case of 3, uh, I just encountered 3 once, so this number will be negative. So I can tell that 3 was the only number. 3 was the number I visited only once. Because if I visited it twice, so I'll mark it as negative. Now you'll be having a doubt that if I get 2 once more, like I get 3 twos. So in the game of plus minus, it will again become negative. But what I'll do is I'll check it from here, and then if the number is positive, I won't change its sign. So by this way, using O of one space, I can tell that how the numbers that are not occurring more than once in my array, if I'm clear with this. Hello?
Hi Tanvi, this is Vipin. What if we have a 3 times this number 1?
That's what I said. I'll make it it's initially plus. Okay, I'll first time I encounter it, I make it negative. Second time I encounter it, I make it plus. But for the third time, I'm having this bit number, which is giving me that the at my third for in case, let's say that I encountered 2 once more. So I'll check it over here that this bit is already turned 1, which
Okay.
means I've encountered 2 once. So what I'll do is I won't change its sign. It's just a simple if condition using bit mask, if I'm clear.
I'm
Hello?
not I'm not clear about the like you're changing the signs. Like you're looking back and then changing.
I'll just give it a try and just a sec. Let's take an example. This is my example 1, 1, 2, 2, 3. Let's take one more 2, 4, 4, and 5. Okay, and I'll make an index array.
And I'm sorry to interrupt, but I guess we are in this question we are having this one number twice. So I don't think we will be having 2 3 times.
Someone said that Vipin said that what if we are having it thrice?
Okay.
So let's take it thrice.
Okay. Okay.
It's not a big deal.
Okay.
Okay, so I'm marking my indexing from 1. Okay, 6 and 7, and here's my bit number 0 0.
So what is the size of this bit number they're talking about?
This bit number is a single 0. Into 0 integer, right?
So 32 bits.
bit. Yeah, 32 bits. So now what I'll do is I'll initially I go to 1. Let me check the color. I go to 1. I mark this index. This index is as it's on first index, I mark it as negative. I go to the second place. I see that I've encountered 1 once more, and the sign is negative. when I mark it as negative, I make the first bit as 1. Okay. Are you following?
Yep.
Okay.
Yeah.
So I am here and I see that I am at 1 once more. I'll make this positive. Okay.
Mm.
Then I come to next thing. I see 2. I'll make the second number as negative. I go ahead again. I see 2. I make it as positive. And firstly, when I saw 2, I'll make the bit as 1 too. Matlab, the second bit as 1 also.
Mm.
Now I move forward. I see 3. I'll make my third index, that is 2, negative. Okay, cool. Now I am at 2 again. I'll check it that the second place I'm here. I have checked my bit is positive, my second bit is positive, and this gives me 1. That means I encountered 2 twice already. So I won't change this sign. Is that okay? Hello?
Yeah.
Okay. Now I'll move forward
Hey, Tanmay,
and
one quick
So I
question, right?
am, yeah.
The reason why you set the second bit was because it's 2, right? What if it was like, 7, then you will set the seventh bit, is it?
yeah,
What if the number is more than 32? What if it was like 100?
that's in my constraints. Okay, so as you have given the condition that my array will be between 1 and n, if it's 64, I can get this thing. And even if it's more than 32 and I don't want to use an integer, I can take 2 of bits like 0 is 32 times more.
So what is the
And
space complexity of this at this point of time?
order of 1, 2
How?
integers. I'm just taking 2 integers.
Yes, but what is 2? 2 is actually n divided by 32, right? At this point of time. So if your n was 1 billion, then how many integers do you need?
Okay. If my n was 1 billion, I won't take an integer, I'll take a long or something. So I get 64 divided by 1 billion. But when we compare this number, it's 64, matlab, 64 to make it 1 billion. When we compare this number with 1 billion, this is much smaller. So we can say that we are using almost a constant space.
No, that is not right. It's n divided by 64, right? N by 2, n by 4, n by 8, whatever that is still equal to n. N divided by constant is still n in terms of space complexity.
Mm,
If you're not speaking, please go on mute. And if you're noisy, then just chat. Go ahead. Sorry, I think I put somebody on mute. So please go ahead, unmute yourself and talk.
okay. I said that in most of the cases that we're doing, we'll be getting an array of size 128, or if it's even more. So I just can have 2 numbers or 3 numbers. That's like too less. As in, how do I explain? For 64 numbers, I'm just using a single integer, right? So, matlab, what I have learned is that we consider this as O of 1 only.
No, actually, I don't think that that's the right way of looking at it. So let's actually let's take a step back and kind of like go through. There are like we're trying to solve multiple problems at the same time. So let's actually restate the problem and just solve them one by one, and that actually will eliminate confusion. So first one is let's solve the problem that's on the table. So Ashish, if you can actually switch to your screen share
Okay.
and just show the problem alone.
Okay, sure.
Yeah. So this question, right, is actually the find all duplicates in an array, right?
Okay.
So the idea here is that you want O of n runtime and you don't want to use extra space. So the cheating here is that you're essentially using the input itself as a mechanism to store the flag, right? So that's the one thing that we talked about already, right? Now, the couple of things here. One of the ways of looking at it is that the input array is generally considered immutable, which means you can't change it, you can't modify it, and things like that. If that were to be true, then you cannot do it in without extra space. You have to have extra space. There is no way to solve this. Now, a different standard that you can hold yourself to is to say that if the input is unmodified, in the sense that what was the original input is the input at the end of the operation, that is still considered like, no extra space, then you're probably okay. So what we are doing is we're using that definition here. So what we can do is you can just change the input in any way you want while the algorithm is running. But once the algorithm is done, you need to reset it back to the original input somehow. And if you could do that, then you are fine, right? So that is the definition that we're using here when we say that we're not using any extra space. And that's pretty much the crux of this conversation. So the way you want to do this is that you want to use the sign of the number. So every number has a magnitude and a sign, right? So 4 is essentially positive 4. It can also be negative 4. Given that you know that all the values are positive in this case, you can actually use the sign as an extra flag and just make sure that you can you can flip that bit on or off and determine whether you have seen that number before or not. And this approach will only work if a number appears exactly twice or exactly once. Because if the number appears 3 times or 4 times, then you will actually keep flipping the bits on and off, and it won't actually work that well. Okay. It will work multiple times. Like, the first time you turn the bit on for 4, the first time you see it, then you turn it off the second time you see it, third time you turn it on again, and fourth time you turn it off again, you will think that this has happened twice. So that may not be the right way of looking at it. So what approach, I think we've talked about this approach a few times. Let me just restate what we will do is we will go through the entire array one by one. We will take the number, like in the example given, we'll take 4. What we will do is we'll go to the 4th location. Since it's actually 1 based and it's less than equal to n, you need to be careful that you're actually not setting the array of 4 as negative, but you're actually setting array of 3 as negative, because arrays are 0 based and the number is 1 based here, right? So you will actually, once you pick the 4 up, you will set the 7 to -7 in this example. Then you will pick the 3 up, and then you will set the 2 to a -2. And then you will pick the -2 up, and then you will actually clean the sign, because you know that the numbers have to be positive. The fact that it's -2 is irrelevant. You just have to take the absolute value of that number. So you take the 2, and then you set the 3 to a -3. You take the -7, you take the 7 out of it, ignore the negative for now, and then you will set the 7th bit, which is actually 2, 3, 4, 5, 6, 7, which is like 1. The 1 becomes -1, right? No, 3 becomes -3, sorry. Then for 8, we'll do the same thing, right? For 8, the 1 becomes -1. For 2, what we will do is we'll go back and take the -3 and make it a +3. The second 3, right, becomes a +3 now. It's exactly what Tanmay explained in his algorithm. That's all we do. We just bit flipping. That's it. Nothing more than that. There is no counting. There is nothing else at this point of time. Now, once you've gone through the entire array, what you will see is that anything that appeared twice, you would have set it to negative and you would have reset it to positive. Anything that appears, like essentially anything that appeared even number of times, in this case is twice. Anything that appeared once, you will be setting it to, it'll be negative. Okay. Now, what happens when something is not even there?
We won't be setting its bit.
Unfortunately, right? So once you do this, so at the end of the array, if a number is positive, then you don't know whether it never appeared or whether it appeared twice, right? You wouldn't know that so far based on how I mentioned. So what change can you do to this algorithm so that you can actually identify when it happened twice?
Could you please repeat? I didn't get. We're already getting that which numbers we got twice, right?
No, we don't know whether it's twice or 0 at this point of time.
But what if I place a condition that I'm not even making it positive once it occurs again? My question is, why are we making it positive? For the first iteration, when I get to second time, I already know that it's
But you are
got it.
so your question is if it is the number is not in there, like
Go
are you
on.
meaning like Vivek, are you asking like if the number is not there, like 0 to n
Correct. So let's
minus
let's go with it, right. So I'm going to
what's the
assume, let's ignore the zero based thing for now. So the question actually says that the numbers are between 1 and include n, right? That's what it says right now. Okay. I'm going to make it simpler for our action. So let's assume that it's actually between 0 and n. This is like actually, open ended. So that way the -1 does not have to happen. Okay. So now the input was given to be like, 0, 1, 2, 3, 4, and 4, right? So now what happens is that after you're done with this operation, 0, okay. You know why you didn't do 0? Because it's actually that you can't do -0, right? That's why they didn't have 0. Now I realize that.
yes.
Okay, so let's assume that this was your input. So what you'll do is that 1 will become -1, 2 will become -2, okay? 3 will become -3, right? 4 will become -4 first, right? And then this 4 will again become +4, correct? Now the problem is that once you are at this particular point of time, this appeared once, this appeared once, this appeared once, this appeared twice, and this appeared 0. How would you distinguish between these two?
Like I said, we could have a bit number.
No, you can't. Bit is actually, that is
Okay,
cheating, and that is big O of n of space. You don't want to do that.
okay.
Vivek, I had a different idea actually when I was doing
We
this.
can let's continue with this approach for now. We'll finish this and then we can switch to the other approaches.
No, I was just thinking about the same approach in this context also.
Okay, if you have a way to extend this, let me
So
know. Like what fix would you do? Go for it.
So, can I ask one thing? The problem over here we are seeing is that because we need to make it as it is, the input as it is, like we need to return the input as it is. That's why we are solving. But while iterating over it, if we see that that number is becoming that number is already negative, that would be our result. But the problem is that we need to make it as it is. The input was provided, correct?
Yeah, that should be that is not a concern as such, because anyway, after you're done with this, right, you can just iterate over it and replace everything with absolute value of that thing, right? So you will be able to do that after that.
Yeah, but then the 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 approach which we are solving is that if that number, if the number which we already make it as a negative, and if that number occurs say again, then we will be making as a we know that number is already negative, and we are making a positive, so that would be our answer. So we will just put it in our result set, and
That is
I don't
correct.
know. Yeah.
That is exactly what I was looking at. So the thing is
Yeah.
that uh, so the thing is that there is, if you actually use this algorithm or approach that we said, the first time you see that number, you will make that plus a minus. The second time you see it, you'll make a minus a plus. The third time you see it, you'll again make the plus or minus. The fourth time. So that's how it will be going on. The thing is that once the whole thing is complete, at that time, you cannot distinguish between whether something was never seen or something was seen twice. However, the second time you see it, you know that the number is a negative and you are making it a positive. So that instance, like this operation, when you do, you know that this number has been seen precisely for 2 times. So at that point, you have to log it. So you can't do it as 3 different blocks. You can't do it as like, I'll do all the bit manipulation or the signal sign flipping once, and then I will look at the final array and then I will find out which ones are appearing twice. You can't do that. For things that appear only once, you can actually do that approach. You can do all the sign manipulation, and then at the end of the operation, you can just go and see which ones are negative. Those have happened only once, right? You can do that. But for the ones that are second time, like, seed for 2 times, you cannot do that. Does that make sense? Perfect, Sonia. You did that was the catch I was trying to get to.
Hi, I have a question.
Go ahead, Rohan.
Yeah, so my question is, so if you look at it from a naive perspective, and you can solve it via sorting or using a hash map, and then you don't fit the constraints, how would you say can you necessarily develop intuition for such a problem? Because it's not an open-ended problem, right? There is only one solution for a problem like this, and a lot of lead code hards I've seen, the problem is that there's only one pattern of solution for this, right?
Can I answer this question?
Go ahead, Sonia. Thank you.
So the thing is, like, when I saw this question, the first thing which coming my I saw in the question is like it's in 1 to n. So which sticks to my mind that it can be which can be solved using this array only because it's in 1 to n. And it's written that it was written that our numbers will also be in 1 to n. So this comes this was a plus one which comes in my mind. I don't know about others, like, but this was the one stick to my mind.
Okay, but that's not a constraint that's enough to tell you that, okay, you can actually manipulate, certain indexes. Like the problem could have been anything else where the constraint is 1 to n. Like that's a very,
I think it's a fair push, Rohan, because again I missed the 1 to n when I was actually trying to restructure it.
yeah, I mean, I think a lot of people did, right? Like it's not.
Fair enough. I mean, good that Sonia, you caught on to that and that gave you the idea. The way I look at it is that I think it is very clear that you need O of n space. There is no other way to do it, right? I mean, you start with this, the naive approach, that you need O of n space. And given that it says that you need to do it in O of 1 space, the most immediate answer that you'll think of is like just sort it, and that will destroy the array, as in the positioning of the array, and then you can just go and do it, and it's fine. And that's sometimes the input is actually considered like freebie space. You can do whatever you want to do with it, so you can work with that. So there are multiple examples of where you can sort the input, or you can do some pre-processing on the input or filtering on the input, and you can just make things work. So that also works. Now, for this question, I think I would have immediately gone and jumped on the XOR approach, which we discussed earlier. Right, the XOR approach is actually useful if you want to eliminate all the things that are appearing twice, and you only want to leave. There's only one element that only appears once, right? If that is the one, XOR will just cancel out all the duplicates, and it will just leave out that one thing that was there. And that is what I would have done first. But then I would have immediately realized that this question is asking for the exact opposite. Like, it's actually asking me to eliminate all the singles and then keep the double at this point of time. So with that, my first instinct would be to use some sort of like a summation algorithm or something, where I would go and find, like, add everything up, or do some kind of like XOR operation or something, and then create like a sum and identify if I can see something is missing. Like one of the examples, I think Cracking the Coding interview has this, was saying that if I give you an array which has all the numbers except one, and that number is missing, find out which number is missing. Right? So I give you an array of size n minus 1. It has all the numbers from 1 to n except 1. So tell me which one. And you can do it mathematically, right? You can just simply add up all the numbers.
Add everything. Yeah.
And then you will have like a mathematical n into n plus 1 by 2, and then you can figure it out. But then that is a problem because you have integer overflow issues. So you may want to do XOR instead. And there are a couple of ways of doing that. So that's the first instinct I had when I looked at this question. Then comes the cleverness, and this one is something that you will not know. Knowing that all the numbers are positive, the fact that you can actually use the sign bit as a bit vector is for free, right? Just keeping track of that is the trick here.
Especially because they're not coming back to those elements again. It's just one pass, right? So
no, even if you come back to element, it shouldn't matter, right? Because the magnitude is different from the sign. The sign is free. You can use the sign for whatever. Correct? Okay. So you have the opportunity to do whatever you want in this case, and it should kind of work. There is another question which actually uses a similar thing, which is called like have you guys seen do you know what the Dutch national flag problem is?
Nope.
Um,
Yes.
can anyone explain this question?
Yeah, essentially, what this says is like you have three type of numbers in an array, and you want to sort it in a way like the first set of numbers come together initially, then you have a middle set which is of second type, and at the end you have all the third type of numbers sorted or paired together.
Correct. So the Dutch national flag question is essentially I give you an array of numbers which have like, negative numbers, positive numbers, and a bunch of zeros. And I want you to actually sort this array to some extent so that all negative numbers come together, then all the zeros come together, and all the positive numbers come together. It's like one of the ways of doing this.
What are
Now,
the
the
constraints?
challenge with this is you have to do it in place.
Okay.
Okay. And there is no good way to do this in place, right? There is no easy way of doing it. So the way you do this in place is that since it's zero in between, you can count the number of zeros. You can actually overwrite and destroy zeros. You don't have to keep track of anything. You just have to move positive and negative numbers left. You just have to switch them around. And if you find a zero, just keep track of how many zeros were there and just keep track of it. And once you run out of both the positive and negative numbers, you can just flood fill zeros in the middle and you're done. So look at this question later. So there's also intuition there. So as you're preparing for different questions, make sure that you understand the pattern. Just solving these questions is in and of themselves is not useful. So when I looked at this question, the czar approach came to my mind for the first time. This is like, now I have seen this multiple times, so it's a different story. But when I saw this first time, like many years ago, I had done the Dutch national flag problem before. So I was thinking about that. And then I had the XOR approach. There are multiple questions of that. And then the epiphany was that I can use the sign bit. Now, if I don't know that, then there is no way you're solving it. The interviewer might be able to drop you a hint, which will actually help you solve it. And you can just say that, hey, is there anything you can do to the number while, preserving it or something like that. Like, and it might just work. So good question. I think we're probably spending a lot more time on this one. I want to make sure that we cover the third question as well. But this question is actually pretty straightforward, and it'll only work if it's twice. So this is like a very hacky question.
Hey Vivek, I will just take 1 minute to add to the intuition part because that was a very good question.
Go ahead, go
Uh,
ahead.
yeah, and it may help in other situation if not in this particular question. So, how you can reach to the solution is, of course, as someone mentioned, what is special about 1 to n. That was a very important observation. Another one, if we are not constant, we would have a Boolean array where we could have marked somehow, but we can't have that because of the space constraint. So we use the existing space since it's like just pairwise, so minus works in that particular situation. Other intuition for the same problem, think like you have there are a lot of chairs in to think about indexes as chairs and you want to sit persons on their assigned chairs. So what you can do when first person comes, you go to the first chair, whoever is sitting there, you move that guy from that to his place. Doing this in a cyclic way, eventually you will find some of the people who are going to their chair and already a person with the same value is sitting there. So you can say, hey, this guy is being repeated. I haven't coded this approach, but in some situations that may work too, and maybe here it may work too. I will have to code it, but just want to give you that approach helps also. Without again space complexity, you will be O of n. Oh, sorry, O of n one. So
Oh, thank you so much. I think it makes sense. So, all right. So Ashish, do you want to just take the screenshot and continue with the third question?
Yeah, fine. Okay, so we're moving to the next last question. Shortest path visiting all nodes. So we are given with the undirected connected graph and the nodes are labeled like 0, 1, 2, and -1. So we have to return the length of the shortest path that visits every node. Okay. So we may start and stop at any node and we may visit a node multiple times. So we can reuse the edges, and the length of the graph is n, and if and j is not equal to I in the list of the graph I exactly once, and only if I and j are connected. So is there any questions regarding the problem?
And do you have to come back to where you start from?
Yeah, yeah.
No,
You may start and stop at any node. So it's written you may start. So it's not necessarily like we have to come back.
Okay.
Any approaches?
Because if you have to come back to the original, I was thinking of something like Floyd's, which, where you visit every node and then you come back. But
Here we may start from start and stop at any node, and we can visit any node multiple times.
I was thinking about on the breadth-first search approach. But the problem is that we need a minimum shortest path. So no, the shortest path is like breadth-first search, but um, we but after doing the breadth-first search also, we are not sure that it would be uh, going for the minimum paths.
Somebody said Floyd here. Like, just want to clarify that that gives you shortest path between each pair, and that will not help you in this particular case.
yeah, it's all pair shortest paths, right? So like,
Yeah.
I'm guessing you can, but the why I'm confused is they've not given which node to start from, which node to end. So I think you'll have to run it from every node once, and then you can figure out which is the shortest path. I'm not sure. That's why I was confused. But
I don't know the approaches. I don't know. I know their names. I had read it in theory. It's actually application of two algorithms, which basically use breadth for search only. The algorithms names are Bellman, Ford, and I guess it was Dijkstra, if I'm not wrong.
yeah, those give you the shortest path, but only considering those nodes once. The catch here, if you see the example, the first example, anything that gives you, it's kind of a star structure. So if you take this stars and try it from any node to node, it will give you the shortest path between those two nodes. But finding a total distance where a node is visited multiple times, that is not possible using Dijkstra's. If you see the output, it has 1, 0, 2, and again 0. Dijkstra's will not come in here.
I got you.
Maybe not a direct version. So I can give you my intuition when I started with this problem. I'm not sure that's correct or not. I could not complete it. So what I did was, if you consider a node and you go to the next adjacent nodes using BFS, and you can come back to the original nodes. But if you can I share my screen? Ashish,
Yeah, I'm stopping my screen. You can share your.
yeah, I'll share the whiteboard. Is it visible?
Yeah, go ahead.
So let's assume this is a structure of a tree, A, B, C, and G. So my idea was to start with, in a queue, have all those initial places set up like A, B, C, and D. And then whenever I'm, expanding the nodes, like suppose I'm expanding A, I'll go to B, I'll go to C, I'll go to D. And in the queue, I'll also add the length of nodes, length of path till that point. And when I'm here, I'll add B comma 1, C comma 1, and D comma 1. So this is nothing but kind of a state of the system which I am maintaining in the queue. So initially it was A0, then I expanded A, it became B1, C1, D1. Now these can go back to the original node, which is B to A, but then the distance will become like A comma 2. And if you see here, I could see a problem coming in where they could just keep ping ponging with each other, like from B to A to B, B to A. So what I did was just keep a note of previous and previous to previous node also. So anytime I see I'm going back to the previous to previous node, I stop there, because I know if there are points A and B, and there's some other section over here, I go from here to here, it is one distance. I go from here to here, it's two distance. Now anytime I ping pong between these two, the minimum distance between those two will always be 1 or 2, or essentially 1 and 2 on the both sides, right? So I stop them using this condition, like your previous to previous node should not be same. I was able to get output for a couple of them, but for the the nodes which become greater than 7, this kind of gave me TLE. I tried a couple of approaches on my machine. They gave the output as correct, but lead code is giving them TLE.
Just one question in your approach.
Yeah.
When you've drawn A to B, you're showing 1 and 2. But it's an undirected graph, is what it says in the question. So you don't have to consider either 1 or 2. It's whether you go from A to B or B to A, it's the same magnitude.
Right. I'm just saying that to stop my BFS tree from going exponentially, like infinitely growing that, this I use the condition to stop it, because when I will use this, this queue structure, at one point in the start, it's A0. When I go to B, it will be B1. But then I come back to B to A. Because the distance would have increased by 1, it would have been giving me A2. Although from the state point of view, it's a different state, but we had to stop here because, it's kind of ping ponging with each other. So I'm just trying to, give why I'm stopping or why I'm not allowing a node go back to, again, its original to previous node. It'll just
Okay, so once it crosses a threshold value, that means, okay, it's ping ponging. You don't want it.
Yes.
Exceed.
Yes. It's kind of pruning the BFS tree where I want to prune it.
So a couple of things you can improve on this algo is uh, you are trying to do DFS essentially, right?
Yes,
That
BFS
is,
and my right. BFS are not necessarily nodes, but these states.
yeah. And as sorry, I'm on mobile, so I can't see your name. So sorry about that. Like, there is no difference between visiting B and then A versus A and then B if the cost is same. Is that fair? Right? Right? I mean, I can start from B and I can reach A, or I can start from A and reach B. Both are same costs. Suppose we have only these two guys, we have to travel,
Right.
right? So also suppose if I have to reach A, B, C, D in any manner, I can start from anywhere in theory. So, so when you are starting your BFS, you can start from all these places. That is one way to optimize things. And then the other thing, like suppose if I have visited A, B, C, D, I can somehow represent that in a bit set or in any data structure which takes a very less time to determine, hey, have I visited everything yet or not? Suppose you just assign because the numbers are for A is 1, for B is 2. You can directly figure out a data structure where you can see if all these bits are set, that I know I have visited everything. I will not further go and look into it. So since there are n numbers, you can see some approaches for for the solution. You will have 2 to the power n such possibilities. And if you try to just go through your approach and use these optimization, this should work. I have solved it earlier, so I remember the basic idea.
Yeah, exactly. So my next, the way of optimizing this was exactly what you said. So, just kind of creating a state based on the start, where I started, how many of the nodes I have visited, and where I am right now. So it was more of, let me just clear some part.
Yeah, so zero, what is the zero in your example? Is it the distance you have covered?
Yes, the length that has been covered till now.
Yeah, but the good thing is that you don't have to keep that in your state, because if you are doing BFS, then as soon as you reach a solution, you know that it's the shortest path for your case. So just by looking at your visited set so far, you should be okay. So like you can save some space there, or maybe time also. I don't know if you are checking on distance also.
Okay, yeah, that. So
What I'm basically thinking of is like I didn't get time to code, but yeah, I thought of approach.
One
Uh,
question, okay? It's already time. So
okay.
just wanted to like finish up with a thought, and then Ashish can just wrap it up. You guys are, I can stop the recording. Feel free to continue discussing, but I just want to close the conversation. Just let's keep it to 1 hour, but we can continue chatting after that. So go ahead, finish the thought.
Mine, right? Um,
Yep, go ahead.
okay. What I thought was let's do it similar to as in case we find the maximum height of the tree, maximum node to node distance within a tree. What we say is that we call our left, we call our right. We say that either my maximum node to node distance will be in left or will be in right or will pass through me. So I'll do the same thing. Instead of calling maximum, I'll call for minimum and I'll call it for all the nodes. What I'll say is give me the minimum distance passing through you for the whole graph, whole remaining graph, and then I'll like have a visited array in that case, and using my recursion, I'll get the answer.
mm, could you explain again? I'm not sure if I get it correctly.
It's basically the same thing. As you just don't erase it. As you said, you'll call from A to B, B to C, B to D, A to B, A to C, and A to D. What I'll do is I'll get my answer from B, from C, and from D, and I'll tell them. I'll compare it. If the shortest distance from B is minimum, shortest distance from C is minimum, or shortest distance from D is minimum. And I'll be having a visited array wherein I'll just check all of them and then I'll add myself to the shortest distance and I'll return it.
Okay, Tanmay, I have a doubt here for your approach. Like, if that you're saying it for a tree, right? So, what if there is a cycle? Since our question is about graph. If it is a tree, that's fine. Your approach is well and good. But what if there is a cycle?
I'm having a boolean array that contains the visited nodes for this case. So if I'm visiting a node more than once, I'll be checking it with the boolean array. It's just an approach. There could be modifications to this.
Mm, yeah.
Okay.
So, is there anything other to discuss? Like, shall I wrap up?
So let's do that. So thank you all for joining today. What I'm going to do is I'm going to stop the recording at this point, and the Zoom bridge is open. So feel free to continue discussion if you think if you want to just discuss in chat more. All right. Thank you, Ashish, for being a host and get going. We actually have questions for tomorrow already posted. So join the Slack and look at the LeetCode channel for tomorrow's questions. See you guys tomorrow at that point. Thank you.
Thank you.
See you.
Thank you.